I have a link to the videos on my website. There's a big link that says all the videos. Or if you go to YouTube, just type in Waller is me, one word. Waller is me, that's my username. It's me, Waller. Huh? On the class website, there's under every single one of my courses, you got a big old link that says all the videos taken so far. Yeah. All right, guys. So I got a question on 21 on page 286. Okay. Uh, 200 passengers. All right, so say. Okay. Wait, am I? I thought you said 6'5", 6'6". Okay. $95. All right, this is probably about Mendel, right? All right, guys. So in this one it says blah 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 blah. That's exactly what it says. That's just weird. So assume that Mendel's 25% rate is correct. So there's a lot of crap to kind of wade through here. And these kind of problems, I kind of just like the way they set some of these up. Sometimes they'll tell you a percentage, and then they say, well, assuming this other thing is correct, we're going to test this other percentage out. So he tried to set up in a certain way, and he got more than he thought he should, right? So assuming that the 25% rate is correct, so assuming that P is 0.25, find the probability that out of the 580, exactly 152. Now part A I can do with just the normal, the binomial probability formula. Right? I really don't have to do a z-score for that, truly. There's a way I could, but it's just one application of the formula. Right? So this would be, what would Q be in this case?
0.75.
0.75. And then how would I set up the formula? Yeah. So 580 things. Choose 152 of them. So I want how many of these? 152. And then how many failures? The rest, right? So a little more specifically, 428, right?
Oh, yeah.
Now, what I'm curious in is your calculator able to handle that? Did you get a number from that? Did you try that?
Yeah, I did.
And it worked? It didn't work? It might be too large of these numbers for the calculator to handle, in which case we would have to do the normal approximation, right? The nav. Let me get ready in case that's the case. Overflow, okay, good. So that's where technology craps out. I think even if you try the binomial PDF, the probability will crap out too. I just get way too large of a number here. So here's the idea. What's the mean for this? So everybody cool with the fact that, or not cool with it, but you understand that this leads to some funky overflow. My poor little calculator says, I can't handle that. So in order to use the NAB, the whole NAB is trying to use a normal curve to approximate a binomial. So in order to use a normal curve to get probabilities, I need a mean, I need a standard deviation, so I can make my score into a z-score and look it up, right? So the mean and the standard deviation formulas for a binomial are beautiful. You can't beat them. So the mean in this case would be, yeah, and they pretty much already told me, 1/4 of 580. Would it come out to be? 145? And then the standard deviation would be the square root of 580, 0.25, 0.75. And whatever the hell that is. It's
10.43.
10.43.
428.
428. Sorry. How are we doing so far? So very often they will give you the mean and the standard deviation for a z-score problem. The binomial is one case where they won't. You can calculate it yourself really easily. Another case would be they give me a list of data, and I've got to put it into my calculator and get the mean and the standard deviation, right? So I've got all these different ways to calculate the mean and the standard deviation. Once I've got them, now it's just an old-time problem. Just one little thing I got to be careful about here in a second. I want equal to 152. So that might freak us out a little bit. What is 152 though? Really, it's from. Nobody thinks about that. That's right. So this is going to seem a little weird, but what I do is I make a z-score out of both of those. I want to find the area between. Don't I want to find the area of this box then? That's what 152 is defined to be, is that box. So to find the area of that box, I have to make those z-scores, look them up, and subtract. So it's all about that continuity correction. When you're trying to use a normal curve, when you have an NPQ problem, you're going to have to change your data point up or down by 0.5. This is one case where I actually have to go both ways, because I just want that one box. I don't want to go up from there, down from there. I just want that thing, right? So you make a z-score out of 151.5. 145. And standard deviation was 10.428. Make a z-score out of this thing. Let's see, 6.5.
For the first one, I got 0.62 or 0.62.
Sounds about right. And you guys still got to be real careful about rounding your z-scores, right? So if it's 0.628, you make it 0.63, but all right. And then this one.
0.72.
All right, good. Should be off by about 1/10. That makes sense. So 0.72. That sound all right? Then you just look those up, get the area, subtract. Kabam. Yeah, so these are my z-scores. One thing I want to make really clear now, a lot of you guys on the test, you got the z-score and you stopped. And somebody would say, well, that's 62%. That's a z-score. That's not a percentage. That's a z-score. I've got to look up the percentage. Make sure that you get all the way to the end. Tell yourself what you're doing. So some of you guys did this work, and it's really easy to forget what the hell you just did. You see that? That looks like 62% to me, and they wanted a percentage. There you go. When if you tell yourself, no, me, it's a freaking z-score. I've got to look up the area now, right? I haven't got the answer yet. All right, so that's how you do that problem. And really, part B is probably the same thing. Part B says at least 152. So if I want at least 152, what side of the bar will I start on? Do I want to include 152? If it's at least 152, yes.
151.
So I'm going to shade up for at least. Am I going to start here and shade up or here and shade up?
First,
Lower or upper? Yeah.
the first year.
Yeah, the lower. Good, I like it. Because you want to include that bar. That took 3 seconds, right? Don't People try to memorize, okay, when it's this, you go up by 0.5. When it's this, and that to me is crazy. Just draw it and take a second to look. I want to start here, so I include it, bam. So you make this into a z-score, right? Look it up in the chart. It'll be the area below. You want the area above. 1 minus what you find, bam, right? That'll be the probability that it's out here. Now, let me see. Let me ask you. I was kind of planning. Let me see if I can do a little bit of this real quick. If the mean is 145 and the standard deviation is, let me see if I can do this real quick. 10.428. Thanks. I could right now just do the max and min, couldn't I?
Right.
What's the minimum expected value and the max expected value? So like 165.8 roughly, right? Add 2 of these. That's like 20.8 added to this. And then take 20.8 minus this, so 124.2 roughly. So I changed those around. Good job, Jeff. There you go. Yay. Now, why would getting 170, first off, what would you call it? If I got 170 then, what just happened? Something that is unusual. Why is it unusual? Good. And remember what we based that on. What's the probability that it's not in here? Maybe we don't remember. Why did we go up and down 2? Yes, 5%. Where did you get 5%? Because within 2, there's 95% for a normal, right? And we could do the whole NP/NQ thing, and it would come out approximately normal. That's why we could use a freaking curve, right? So that's unusual, not because the probability of exactly 170. Did you calculate the probability of exactly 170 before you could answer me? No, you just know that that's in an area that's unusual, right? So we got to be real careful when we start getting to these problems that are a little more dense, not like 0, 1, 2. And then if the probability is 0 is 0.04, is that unusual? Yes, it's less than 5% chance, right? But there's only 3 freaking things here. When I get basically an infinite number of things, I can't look at the probability of a single thing. Would it be unusual for a dude in here to weigh 180 pounds? Would you go, holy crap, you weigh 180 pounds? Of course not. But think about this. It would be very unusual for me to randomly pick somebody who weighs exactly 180.49623492554444444 pounds. That would be unusual, but is it really unusual in the way that we want that word to mean? No, you just happen to be really precise. It's not unusual because it's where I expect it to happen. It's not the specific value itself, it's the area it's in. Right? That's going to become really important very soon. Okay, so I'll hit that same idea later. But we see this right here. You did not calculate the probability of 170. You didn't have to, and in fact, it's misleading sometimes if you do. You just know it's in an area where you don't expect things to happen. Period. Okay. So obviously, right now, it's not tremendously important you understand that, but it's going to come up. I just want to point it out now. Just put that seed out there. All right. Ooh, any other questions?